So this is our first set of videos about Laplace transforms, which is very exciting. People tend to like this section, so I tend to like when we get there. We're going to spend a lot of time with Laplace transforms, and so this video is about some properties that come up over and over again, so I really want you to make note of them and get comfortable using them, and then also the general setup for how we use Laplace transforms to solve differential equations. So, beginning with just some important properties of Laplace transforms, including getting the notation down, we're going to say that the Laplace transform for a function f of t is denoted by L of curly bracket f of t. So that's applying the Laplace transform to f, and we'll denote the output of the Laplace transform as capital F of s. So we'll just use little letters to denote functions that live in like t space like we're used to, and then capital letters to denote functions that live in s place where Laplace transforms move them. Then to undo this, we have the inverse Laplace transform, which is denoted by L with a little inverse sign. And it's going to be applied to those capital F's that already live in Laplace transform space. We just want to undo Laplace transform. And it takes us back to little f of t. So we'll be seeing a lot of these Laplace and inverse Laplace operations. What's important to know about them is that both are linear operations. So if you want to take L of some number alpha times f plus some number beta times g, where f and g are both functions, then the output of that is going to be alpha times capital F, as if you took the Laplace transform of little f, plus beta times capital G, as if you took the Laplace transform of little g. And then inverse on Laplace transforms are going to work the same way. So if I want to take inverse Laplace of the thing I just did, it's going to be alpha times f, little f, a function of t, plus beta times little g, a function of t. And we'll use that linearity a lot to sort of manipulate whatever we see in an ODE to match that list of Laplace transforms that we have available to us. So for example, if we wanted to find the Laplace transform of 1 over s to the 5th, we're going to remember that Laplace transform of, it must be an inverse Laplace because it has to do with s's. Inverse Laplace of any n factorial over s to the n plus 1 is t to the power n for numbers n equal 1, 2, so on and so forth. So in this case, we have s to the 5th on the bottom. So that means our n plus 1 is 5, or n is equal to 4. So for the specific function that this seems to look like, the property I know is that L inverse of 4 factorial over s to the 4 plus 1, which is 4 times 3, forgot my L inverse. L inverse of 4 times 3 times 2 times 1 over s to the 5. That's L inverse of 24. 4 times 3 is 12, times 2 is 24, over s to the 5th. And if I was asked to calculate that, I would just have t to the 4. But in this case, I actually need L inverse of 1 over s to the 5, not 24 over s to the 5. So to take care of this, we're going to multiply by 1 in a clever way and then use linearity. What's going to happen is I'm going to note that 1 over s to the 5, I'm going to redo that minus 1 because it's very ugly. 1 over s to the 5 is the same as 1 over 24 times 24 over s to the 5. So when I say multiply by 1 in a clever way, 24 over 24 is 1. So if I have 24 on top and I undo it by 24 on bottom here, I haven't actually changed what's inside the curly brackets. But then by linearity, I know that this number 1 over 24 can come out of my inverse Laplace. I'm left with inverse Laplace of 24 over s to the 5, which is something I already know how to calculate from the line above. So I'm left with 1 over 24 t to the 4. And so just remembering to do this little multiplication step will get us through a lot of problems in this section. So if that's uncomfortable for you, just keep practicing and you start to get used to finding the number you need on top and just adjusting accordingly. We'll go ahead and do I forgot to move us down to the example portion, but it's fine. I'm going to move us down now because we're going to do another example using the same type of property. So now let's say, sorry, I wanted to take inverse Laplace of minus 2s plus 6 over s squared plus 4. And some things that I'm going to need in order to finish this problem are going to be that we know L inverse of k over s squared plus k squared is sine kt, and L inverse of s over s squared plus k squared is cosine kt for numbers k. So since we're looking at s squared plus 4, that means that our k squared is 4, so our k is 2. So we're thinking about things that look like sine 2t and cosine 2t. That means we need to see things that end with L inverse 2 over s squared plus 4, or L inverse of s over s squared plus 4, in order to apply the Laplace transform properties that we already know. For this big fraction that we're given, we're not quite at that point, so let's go ahead and do some algebra, move things around. So we've got that minus 2s plus 6 over s squared plus 4. And the first thing I'm going to do is I'm going to break up this fraction. So remember, if I have sums in the denominator, I cannot split them up. That s squared plus 4 has to stay together forever. But if I have sums in the numerator, I can split them up. So I can do minus 2s and 6 separately. And that's exactly what I'm going to do. I'm going to say the sum on top is confusing to me. I can do s's or I can do numbers. I cannot do both. So I go ahead and split them up. We're getting closer to what I need. So I could go ahead and, do I have room on the right here? I'll start a new line because we're not going to use all the space here anyhow. This is kind of close to what I need, except for that I'd really like to have s by itself on top instead of minus 2s. So I'll just move that minus 2 out front of it. And then to use this inverse Laplace, I need to have 2 on top, not 6. But I note that 3 times 2 is 6, so I can just move this 3 over to the side. And then if you were simplifying, you could distribute over and it looks exactly the same as above. This is when linearity comes in. So this is like my alpha f, my beta g. So I know that this is minus 2 L inverse of s over s squared plus 4 plus 3 L inverse of 2 over s squared plus 4. Or I'm just looking at minus 2 cosine 2t, the one with the s on top, plus 3 sine 2t, the one with the k on top. And that's how I take that inverse Laplace transform. So I'm going to end the video here. Hit pause if you're still working through that. And then next up we'll talk about how to add derivatives when we're taking Laplace transforms.